Mhm. So let's start. Please open class 9, game theory. But the first task is, I think it's not about game theory, but about perfect competition, for example. But anyway, you can explain how you want. So I will read, then maybe somebody wants to answer. In 1970, United States Congress banned cigarette advertising on TV. As evidenced by the steadily declining proportion of smoking Americans, this law seems to have achieved its state purpose of protecting national health. But the law also had an unintended effect, which was to increase the economic profit of cigarette makers due to cuts in advertising budgets. But the question, if eliminating television advertising made companies more profitable, why didn't the manufacturers eliminate the ads on their own? Maxim, please. Why?
Because it's rather difficult for all cigarette producing companies to eliminate their advertising at the same time. So if, for example, one producer eliminates their advertising and the others do not, the first producer will obviously lose a ton of benefit and the others will get it. And it's extremely difficult to achieve without government intervention to achieve a point at which everyone will stop advertising their production, and after the government intervened, then they kind of started benefiting because they got in the same position, I assume.
Yes, exactly. It's perfect answer. Thank you. Maybe somebody wants to add something. Will you say? No?
Yes, I'd like to contribute to the previous speaker. And first of all, we should say probably because the cigarette producer were thinking that spending money on advertisement will bring them more money than just having just not spending, because I think they were thinking that it's good investments in their product, and that's why they weren't thinking about it.
Yeah, exactly. Diane, do you want to add?
Yeah, I just quickly wanted to say that it happens when there is an external force, let's call this way, changes the rules of the game that a producer of, in that case, a producer of cigarettes cannot have any effect on. And that is the reason why it's basically about adapting to certain situations. So in case there are no ban of TV advertising, then they're pretty much comfortable because that's the way the game's rules work. But when the game changes, they have to adapt to this new rules because they cannot have any effect on them. So basically, that's it.
Yes, okay, thank you. So let's write down a little bit our answer. Yes, so in our game theory approach, if there is no ban, and we start from a situation that nobody make advertisements, no ads, this situation without ban is not equilibrium situation, yes? Why? Because each firm wants to deviate, and they will deviate and make advertisements, yes, to make their profit bigger. Firms independently to each other deviate such that profit increases. And equilibrium situation without the ban in equilibrium, everybody does advertisements. So this equilibrium situation, it's not Pareto efficient, but this is Nash equilibrium. Then, if government introduce the ban, so it's prohibited to make advertisements. and no one can deviate. Yes, because it's prohibited. That's why it is equilibrium. And that's why they can make bigger profit. So with government intervention, here is Pareto improvement. Yes. Because everybody has higher profit. So this is exact explanation in terms of game theory. You can also, I will not write down. You can also tell that you can also explain this in terms of short run and long run equilibrium. You can say that if they will cut their spendings on advertisement, then what that means? That means that their fixed costs in the short run will decrease, yes, and that means that profit in the short run will increase. But this advertisement, what advertisement does? It invite, I don't know, it grab consumers. Yes, this advertisement increase the demand. So in the long run, this advertisement effect will, if there are no advertisements, it will decrease the demand. And that means that if demand decreases, prices decreases, yes? And that means that in the long run, the profit without consumers will decrease. So this cut in advertisement spendings increase profit only in the short run. This is the explanation from long run, short run point of view. But this is from game theory point of view, exact answer. Because our topic today is game theory. Okay, good. Thank you. Number 2. Number 2, we will speak about simultaneous game. So what we have, let's write down. So we have seller and buyer, 2 players. Yes, seller and buyer. Seller, the first player, buyer, the second player. Strategies of seller to offer good product or bad product, quality, good or bad. So first player has 2 strategies. 2 strategies of buyer to buy this product or not buy. And if they will choose strategies simultaneously, they will have payoffs. The game ends and they will have payoffs. So on the first place, we always write down payoff of the first player. So if seller will play good and buyer will play buy, so the seller will get 2, payoff 2, and buyer will get 5. So the payoff of the second player is 5. And here -3, 0, here 4 minus 5, and here -1, 0. Point A. So this is the matrix form of the game, of simultaneous game, and you should write down this, that players play simultaneously, choose the strategy simultaneously, simultaneous game. They choose their strategy simultaneously and independently to each other. Point A. Does the seller have a dominant strategy? Anastasia, please.
To answer to this question, we need to take a look at the, we need to, how to say, сравнить, I forget the word. compare, yeah, two strategies of seller, and we need to take a look at seller vertically, not horizontally. So we compare 2 and 4 and -3 and -1. So in this case, we see that 4 is better and -1 is also better. And so we can conclude that seller in any case would want to produce bad product. So the producing bad product is the dominant strategy of seller.
Yes, exactly. Thank you. So let's write down this. What means dominant strategy? Dominant strategy is the strategy which you choose no matter what your opponent does. Yes? So here we see that seller will always choose bad strategy. How we concluded. How seller thinks. If my opponent buyer will buy this column, it's better for me to play good or bad. It's better for me to play bad because I will have 4 instead of 2. We compare these two and put here dash. Yes, and the same time. If buyer will play not buy, it's better for me to sell bad product because I will have -1 instead of -3. Yes, so. And if we have in the table, if we have 2 dashes in the same row for the first player, so this is the dominant strategy. So let's write down this. Bad is the dominant strategy, and always explain why you chose it. Because as 4 bigger than 2 and -1 bigger than -3, and this is at the same time. You should put here explanations in these tasks. Okay, so good. What about buyer's dominant strategy? Buyer's dominant strategy. Once, Ivan?
I suppose that buyer does not have a dominant strategy because the outcomes are different, and if, for example, he buys or not buys a good product, the difference will not be the same as if he buys bad or not buys the bad product.
Okay, if the seller will sell good product, it's better for the buyer to do what?
To buy, yeah.
Buy,
to buy the
because
product.
here, yes, payoff of the buyer on the second place, we compare 5 or 0. If he will buy, he will have 5. If he will not buy, he will have 0. So 5 is better, put here dash, yes? And if the seller will sell bad product, it's better for him to do what?
Not to buy the product.
Not to buy here, yes, because 0 is bigger than -5, yes? And
Yeah.
we see for the second player that our dashes are not in the same column, so our buyer's choice will be dependent on seller's strategy. So that means that buyer has no dominant strategy. Yes. He has no dominant strategy. And explain as. Let's write down. He will buy if seller plays good, and he will not buy if seller plays bad. And also explain with the numbers. 5 bigger than 0 and but -5 less than 0 at the same time. Okay. So you can explain like with phrases, or you can explain with numbers. Okay. So guys, please questions about this. Okay, I think it's easier. Yes. So point B, we should find Nash equilibrium in pure strategies. And to answer, is this Nash equilibrium Pareto efficient? So Nash equilibrium is the situation, is the set of optimal strategies of buyers, of players of the game, such that no one wants to deviate from the chosen strategy. So here, what will be in the Nash equilibrium. Anastasia?
So here we can say that even in your like drawing, we can see only one situation where you underlined two numbers. In this situation is going to be -1 and 0. So it is not strange that even though like the buyer is in this situation, buyer is better off because seller would gain like -1. But still, this situation is a Nash equilibrium. I almost answered the next question, and then I realized that is like you didn't ask it. You didn't ask it yet. So
Nash equilibrium. What I should write down?
but we don't write numbers in answer. So we write Nash equilibrium. We write seller bad and buyer not buy.
Yes, exactly. Thank you. So here in the table, if you have two dashes, so this is the situation of equilibrium, that no one wants to deviate from the strategy. But in Nash equilibrium, we'll write down strategies, not payoffs. It's typical mistake to write down in the answer -1, 0. It's typical mistake, and you will get 0 if you will write it. So here, Nash equilibrium, set of optimal strategies. Strategy of the first player seller to play bad. So on the first place, it's the strategy of the first player always. On the second place, optimal strategy of buyer, not buy. So he will not buy. And equilibrium payoffs. How much they will get if they will play these optimal strategies. This is -1 and 0. So if your task is to find Nash equilibrium, your answer is this, two strategies. If you're asked to find equilibrium payoffs, this is your answer, okay? So then, Anastasia also answered that this situation is not Pareto efficient. How we also can explain this? Maybe somebody wants to continue. Maxim, Nikitin.
Yeah, so this situation is not Pareto efficient because we see that there is a decreasing while somebody gets profit or does not get anything. So the question where it will be Pareto optimal, and the answer, as I understand, when seller is good and buyer buy, when both subjects get profit, 2 and 5.
Yes, 2-5 is Pareto efficient situation, but explanation should be a little bit different. Maybe.
Okay, maybe somebody else.
Ivan Zamkovy, please.
Yeah. So in this combination of strategies, not everyone are better off, and so someone else is worse off. That's why it's not a Pareto efficient combination of strategies.
Okay.
Yeah, it's obvious, unfortunately.
Okay, Pareto efficient situation is the situation that we cannot make Pareto improvement. In this situation, we cannot make somebody better off without making other worse off. So, in situation of Nash equilibrium -1, 0, we can make Pareto improvement. We can switch to good buy, and seller will be better off. He will get instead of -1, 2. He will be better off, and buyer also instead of 0 he will have 5. So to change our payoffs from -1, 0 to 2, 5, this is the Pareto improvement. So if we have Pareto improvement, that means that -1, 0 is not Pareto efficient situation. Let's write down it. Not Pareto efficient, as we have Pareto improvement. Pareto improvement to play a good buy and explain. Everybody will be better off. 2 bigger than -1 for seller and 5 bigger than 0 for buyer at the same time. This is the explanation about Pareto improvement. So, and you see in this point that our Nash equilibrium and Pareto improvement and Pareto efficiency, they can be at the same time, or Nash equilibrium can be not Pareto efficient. It's okay. So A, B, C. And then we need to write down all Pareto efficient cases. So situation good buy, when they have 2, 5, is this situation Pareto efficient? Do we have Pareto improvements from this situation? Please answer. Who wants?
No.
No. So if we change, yes, we see that buyer will be worse off because 5 is the biggest payoff. Here 0, 0 minus 5. So this is the best. If we will change, so buyer will be worse off. So we do not have Pareto improvements. So good buy when we have 2, 5 is Pareto efficient. So okay, let's write down 2, 5 Pareto efficient as no Pareto improvements. Then other
two situations are not Pareto efficient because we have at least one participant who is worse off.
Maybe somebody found another Pareto efficient situation. Dayan? No?
No, I think I forgot to lower my hand.
Okay.
Can there be any possible outcomes that are not mentioned in the table, or we consider only those that are there?
Only four situations. So you see that situation bad and buy is also Pareto efficient. Why? Because if we will change this situation, seller will be worse off. So we do not have Pareto improvement from this situation. You see, seller now has 4, and if we will change, he will have 2 or minus 3 or minus 1. He will be worse off. So we do not have Pareto improvement, okay? So 4 minus 5 is also Pareto efficient situation. We cannot make somebody better off without making other worse off. This 4 minus 5, also Pareto efficient. No Pareto improvement. Guys, please questions about this? Okay, why minus 3, 0 is not Pareto efficient? Because we can make everybody better off. Yes, from minus 3, 0, we can switch to 2, 5, and they both will be better off. So the minus 3, 0, not Pareto efficient. Okay, so questions about this task, please?
Yeah, I'm sorry, I do have a question, but isn't like, am I right that in any case, it's better for the buyer not to buy a product?
For buyer, it is better to buy if seller will play good, because buyer will have 5 instead of 0 if seller will play good. If seller will play bad, for buyer it's better not to buy, because 0 is bigger than minus 5.
Oh, okay, thank you.
But in the equilibrium, they will both play, they will both have this outcome, equilibrium outcome. Buyer will play not buy, seller will play bad. And this situation will be stable. No one wants to deviate from this situation. This is the definition of Nash equilibrium. No one wants to deviate. Okay? So I erase, we continue. Number 3 is about sequential game. When we have, when first player moves first and second player moves second. Let's see. So we have the game. Let's write down, let's draw the game tree. Game tree. So the first player moves first. This is the beginning of the game. Put here dot and write down who plays in the beginning of the game. Airbus. Airbus choose to build the new plane or not to build. New plane, no plane. Then, after Airbus chose his strategy, then Boeing choose what to do. Here Boeing, here Boeing. And Boeing also choose to build the new plane or not. So we name the branches of the tree as choices of our players. So first player is Airbus, he moves first. Boeing is the second player, and his decision depends on the move of the first player. Yes, we see this. And in the end of the game, we have payoffs. If they both will build new planes, they will have -10, -10. On the first place, this is the payoff of Airbus of the first player. On the second place, the second player Boeing. Then, if Airbus will build new plane and Boeing will not, so Airbus will have 50 and Boeing will have 1. If Airbus will not build new plane and Boeing will build, then they will have vice versa, 1 and 50. And if they both will not build planes, they will have 10, 10. Point A. So this is the game tree. Game tree consists of the beginning of the game, then branches, choices of players and payoffs. По-русски, давайте, это дерево игры, оно всегда состоит, посмотрите, оно выглядит реально как дерево, да, то есть у него есть корень дерева, узел, да, первый узел, да, начало игры, корень дерева, потом есть веточки, которые подписаны выборами игроков, и в конце это как листва, да, обязательно каждая веточка должна заканчиваться выигрышами, да, ну как плодами, может как угодно запоминать. Okay, so, point A. Boeing threatens to enter the new market too by supplying the new plane, if Airbus supplies the new plane. So, threat. Boeing says, I will build a new plane if you will build it. Boeing will build Is this threat a credible threat? Елизавета, please.
Well, I'd say that no, because for Boeing it would be less profitable than not to build a plane.
Let's see. Yes, exactly. It's not not credible threat. Why? Because if Airbus will build a plane, Airbus will build new plane. Then it's better for Boeing not to build, but it's better for Boeing not to build. Why? Payoff of Boeing in the if he will not build, -1, and it's bigger than -10 if he will build the new plane. Yes. He will, so his threat will be not credible. Let's write down this. Not credible threat, as if Airbus will build, then Boeing will not. And explain, will not, because his payoff -1, put here dash, bigger than -10. 1 bigger than -10. This is the explanation about credible threat. And then we should find a subgame perfect Nash equilibrium. So we should find this point, subgame perfect Nash equilibrium. So we should find optimal strategies of our players in each subgame. My first question. How many subgames we have in this game? Who knows? Anastasia?
I guess 4.
Let's count. Subgames. 1 subgame.
I mean,
Second.
okay, yeah, sorry.
Second, yes, and third. We have 3 subgames. So subgame perfect Nash equilibrium. Our chosen strategies should be equilibrium strategies in each small game, in subgame. What means subgame? Давайте еще раз по-русски тоже объясню. Подигра, вот этот subgame, это маленькая игра внутри дерева. Маленькая игра всегда начинается с какого-то узла, вот с точечки, и всегда заканчивается листвой, то есть выигрышами. И мы здесь считаем, сколько у нас подигр. 1 подигра, видите, маленькая игра. 2 начинается с узла и заканчивается выигрышами. И вся игра — это тоже подигра. Ну, тоже, да, видите, она с узла начинается и заканчивается выигрышем. 3 подигры. И мы должны выбрать, что будут делать наши игроки в каждой подигре, да, и чтобы это было оптимально. Окей. Next. How we'll solve it? How we'll solve sequential games? Please answer who knows.
We need to solve it like from backwards.
Mm-hmm.
Induction something.
Backward induction, да, обратная
Yeah.
индукция. Mm-hmm. Sequential games we solve with backward induction. Mm-hmm. So we should consider, first of all, small subgames, and then move back and to consider big subgame. Okay, let's do it. Consider this subgame. If Airbus will build new plane, what Boeing will do? Daniil.
Okay, I think quite obviously if Boeing is choosing between a loss of -10 and a gain of 1, they'll obviously choose to gain 1.
Mm-hmm.
So the
Well,
second option, yeah.
Not. Yes?
Yeah.
Mm-hmm. And here, if Airbus will
here,
play plane,
well, Boeing will choose to gain 50 instead of 10.
so he will play new, because 50 is bigger than 10. Okay, move back to Airbus. What Airbus will do?
Okay, so I think we should look at the first question actually and see that I think the most sensible thing for Airbus to do is to build a new plane, actually, because even if they do that, and even if Boeing does threat to build a new plane for themselves, that threat is not credible because everyone incurs the loss. So it only makes sense to build a new plane for Airbus. So yes, go up.
Mm-hmm. New plane. Thank you. So I will explain. Thank you. I will explain one more time. So we consider what the second player will do. So we understand that if Airbus will choose new plane for Boeing, it's better to not to build this plane because 1 bigger than -10. Yes, payoffs on the second place of the second player. So we consider this branch. Mm-hmm. And in this situation, Boeing will build new plane because he will have payoff 50 instead of 10. We consider this branch. And when we move back, and consider Airbus, Airbus understands this. And Airbus understands that if he will build new plane, then after him, Boeing will not build. Yes? And if he will not build the plane, Boeing will build. So we should consider only these branches, what Boeing will do. Yes, so if Airbus will build new plane, Boeing will not build, and Airbus will get 50. You see? And if Airbus will not build plane, Boeing will build, and Airbus will get 1. But 50 is bigger than 1, so we choose 50. So we will build new plane. Okay, and maybe somebody knows how to write down subgame perfect Nash equilibrium. What will be the optimal strategy of the first player and optimal strategy of the second player? Anastasia?
Well, that's easy. So firstly, we need to write down. We write not numbers but strategies. That means that we write a new plane for Airbus, and then we need to show that we have like new plane and not no plane for Boeing. Like the situation that Boeing has no plane. But we need to show that this is the case where Airbus would play new plane, because we have the same like three, I don't know, like things. So we have two situations where Airbus plays no plane. That is why we need to show that what exact thing we choose. Yeah, so we write down, I think maybe like new plane comma and not for Boeing no plane.
For Boeing not plane. Okay, this point, right? But then we should continue our explanation of optimal strategy. So we see what Boeing will do. Please pay attention to this. Boeing will not build if Airbus will build, and Boeing will build if Airbus will not build. This phrase is the strategy, the optimal strategy of the second player. This big phrase is all optimal strategy. So how we write down this? Boeing will play not if A will play new, and Boeing will play new if A will play no plane. So this is the optimal strategy of Boeing. This big phrase. Typical mistake to write down the optimal strategy of Airbus new plane and optimal strategy of Boeing not. This is not subgame perfect Nash equilibrium. This is typical mistake to write down like this, because optimal strategy is the rule for you what to do in any case. And we should write down what Boeing will do in any case. And then we will have only this payoff. Only this choice will be played. But strategy can consist and will consist two choices. What to do if my opponent will play his strategies. So my question, how many strategies does Airbus have? The first player, how many strategies has? Please answer.
2.
2.
Two, yes. To build or not to build, yes. And how many strategies Boeing has?
4.
4 strategies. And you see, 4 strategies of Boeing to play, always to build, to play new, always not to build, not, then crossed choices, not to build if Airbus will build, and build if Airbus will not. And vice versa. For strategy, Boeing will play new if Airbus will not build, and Boeing will play not if Airbus will not build. So 4 strategies, and optimal strategy this one. To build new, no, not to build if Airbus will build, and to build if Airbus will not build. This is the optimal strategy in sequential games of the second player here. So, and this is typical mistake, not to write down whole strategy. This is not here for Boeing. It is only the choice. It is not strategy. It is only the part of strategy that matters here. So not for Boeing is only a part of strategy. One more time. It's only the choice. But full strategy is this one. And in Nash equilibrium, we should write down optimal strategies, not choices. Okay. So, okay. Guys, please, questions? Okay, good. I will erase a little bit. Okay, I will erase everything. Point B. Suppose that before the game, Boeing invests 12 million in the design of the new plane. This 12 million of preliminary investment won't affect Boeing's profit if it builds the plane, but will just be lost if the plane is not built. We should redraw the game and to find the same. Okay, let's redraw. So one more time, we have Airbus, beginning of the game. 2 strategies, build or not. Then Boeing decides to build or not. But payoffs are different now. Okay. Where will be, who wants to fill in our payoffs? Ivan?
Okay, so the first strategy won't change. It will be like -10, -10, as it was.
Yes. Then?
Then it will be 50 and -11, because the
Yes.
Boeing loses 20 million, 12 million.
-11. Instead of 1, here -11, yes.
Yeah. So then it will be the same 1 and 50. And the last 10 and -2 is, yeah.
10 and -2. So he loses his investment only if he will not build. Yes. So here we should decrease by 12 each payoff. Okay, good. Thank you. So what about credible threat? Is this threat of Boeing, here Boeing, please do not forget, is now the threat of Boeing is credible? Maxim?
I assume that it's still not credible because it anyway loses if it decides to compete with Airbus. No.
Okay, what's happening now? If Airbus will build the plane, the threat of Boeing, I will also build the plane. Now it is
Well,
profitable.
now it will lose less, apparently, but it will still lose. But if it loses less, can we still count it as a credible threat?
Now we can count it as a credible threat, because now he will definitely do it. Yes? Because if Airbus will build the plane, Boeing will build, because here his pay of -10 is bigger than -11. Yes? So now he will choose to build instead of not. So now the threat of Boeing is credible. Now threat of Boeing is credible. He will definitely do it. He will build as he promised. So then, Anastasia, please solve the game.
Okay, now first of all, we need to look at the first sub game. It like the upper game. We compare a -10 and -11. Obviously, -10 is better. And when we compare 50 and -2, obviously 50 is better. So then we need to look at the Airbus and how he will act. We compare -10 and 1, and he would choose 1. Now we see that our sub game Nash equilibrium has changed, and for now, for ours, Air Boeing, the situation would be not to build the plane, and for Boeing to build it.
To build in any case.
Yeah, to build it in any case.
Always build. You can write down like this. Always build. Good. Yes. So this preliminary investment, is Airbus better off with such preliminary investment? Or who made this? Boeing. Boeing is better off compared to the previous situation now.
Yes.
Yes, exactly, because he will have 50.
Yeah. In any case, he would build and still get 50.
Mm-hmm. Yes. So this preliminary investment makes Boeing better off. So let's write down this with preliminary investment. Boeing is better off. And explain this, because before he had 1, yes, without investment, as I remember, 1, and it is less than now he has 50, yes. Mm-hmm. Good. Guys, please questions about this. Okay. Okay. So I think this is the end of game theory class. Please open the next class about externalities and public goods. So let's see. Today, now we will speak about, I think we have time to speak about externalities. What is the externality? You can explain to me in your own words. Елизавета, please.
Okay, so this is either a profit or a loss that an agent gains or loses, not because of his choice, but because of the actions of others on the market.
Mm-hmm, mm-hmm. Yes. So this is the situation when we we make our choices and we do not think about other people or other companies, something like that. And when with our choices, we influence other agents, yes? So, and we can influence badly or positively. So we will have positive externalities or negative externalities. Let us read the first problem. We should consider the market for vaccines against contagious disease. On the one hand, buying and using a vaccine has an immediate effect of reducing your personal probability of getting infected. On the other hand, it also reduces the probability of other people getting infected by communication with you. So, so when you are vaccinated, you make for you better off, and for other people around you also, you make better off. But you do not think about other people around you. You think only about you. Yes. Thus, the more people who are vaccinated, the less likely a disease will become prevalent. But the less likely the disease, the lower the private benefits to people from getting a vaccination. So that means that we have problem that a little one, that a few people are vaccinated. Point A. Point A. Is this an example of a positive or negative externality? Please, Mr.
I'm not sure, but I still think that this is the positive externality because the society is like even everything. Society still is better with the vaccine.
Yes. So this is the example of positive externality because with our choice, we make other people better off. Yes. So is it related to consumption or production of vaccines?
Consumption. It's a tricky question because, well, why cannot we say that this is also not only consumption?
No, our question is about externality. This
I thought about the whole problem.
No. This is consumption or production externality. Consumption externality, yes, because with our choice we influence other people. It's not in production. Yes, problem. Then, is the marginal external cost benefit generated by each vaccine constant, or does it vary with the number of vaccines? Oh my God. Okay, let's write down answers for the first two. So you will have it in your notebooks. So, what is the problem? Let's write down. More people vaccinated. That means that less likely all around will have disease. And that means that we have the decrease of private benefit from vaccine. And now here is the problem that not a lot of people get vaccinated because of this. And this is the problem of under demand, yes? Недопотребление, under demand, or under consumption. This is the problem of positive externalities under consumption. So we have here positive consumption externality. So what we can say about marginal external, okay, let's consider marginal external benefit generated by each vaccine. Does it vary with the number of vaccines or not? Marginal external benefit. Will you say?
I guess it varies, and the more vaccines are population gets, the less marginal revenue from yeah, external revenues getting, I guess.
Not revenue, but
Not revenues, but benefits.
benefits for other people. So more people are vaccinated, the more is this external benefit. Yes, maybe, why not? And what about marginal external cost? Who knows? Okay, so I don't like this question because you can explain like, yes, it will be growing with the number of vaccines, or yes, it will be constant, and you can explain like this or like this. So it's not a strict question with the right answer. So let us draw typical situations that we can consider in B. We should illustrate the social losses from this externality with the supply and demand diagram. The standard things. 1B. So horizontal axis, number of vaccines, quantity. Vertical axis, everything that we count in dollars. What I should draw here? I should draw, so marginal private benefit, marginal private cost, marginal social benefit, and marginal social cost. What we know about social benefits and costs. Marginal social benefit consists of marginal private benefit of a person and benefits of other people around this person. How we name them?
Marginal public benefit? Or
No,
society,
it was
society. SB, I think. No?
no. It was in the first point. Marginal external.
Oh, external.
Marginal external benefit. And marginal social cost equals to marginal private cost, yes, plus marginal external cost. But if we have here, let's answer the first point here from these things. If we have, you see, consumption externality. So we do not speak about costs. We do not speak about production. So we do not have here externality. You see, external, that means externality. It's about this. So if we speak about consumption externality, we do not have externalities in production. So marginal social costs will be equal to marginal private costs. We will not have marginal external costs. They will be equal to 0. As no production externalities here. And marginal external benefit we have, yes, because we have consumption externality. Yes, because society consists of me and people around me. So from private benefits and external benefits. And this marginal external benefit is positive, greater than 0. Yes, because we make other people better off. It's because it's positive externality, not negative. Is bigger than 0 as positive externality. But about increasing external benefits increases with the number of vaccines, we can say yes or no. It doesn't matter here. You can explain like this or like this. So let us draw. Okay. Marginal private costs equals to marginal social costs. Costs we need to consider increasing. It's in the task, typical graph. Let's do like this. So this will be marginal private costs equals to marginal social costs. And marginal social benefits and marginal private benefits. We should draw these two lines, and you see that they are different. They are different by marginal external benefit. So marginal social benefits will be bigger than marginal private benefits. This will be marginal private benefit. This will be marginal social benefit. And the difference between them, this difference is marginal external benefit. This difference is marginal external benefit. So I get benefit from vaccination, and people around me get benefit from my vaccination. That means that society gets more benefits from my vaccination than me. You see this? So, and what we will have? What will be the equilibrium situation here? Please, who wants to answer? Equilibrium situation. What I will do? How much I will? How many vaccines will be done? Equilibrium will be here or here, in this point, or in this point.
In upper point.
In the second one.
I'd say lower.
Yeah.
But this is the problem of externalities that you see under consumption.
Oh yeah.
I will do what I want to do. We all are egoists. I don't know how to explain more. We think only about ourselves. So I will equalize my private benefits with private costs, and here will be the equilibrium number of vaccines. You see? Okay. But so this is the equilibrium number of vaccines. Let's write down. Marginal private benefit we equalize with marginal private costs, and from here we will have equilibrium number of vaccines. Equilibrium. But what can we say from society point of view? What will be efficient situation from social welfare point of view? So our social planner or government, it will cross marginal social benefits of all people with marginal social costs. And Pareto efficient situation to produce more vaccines, not to produce, but to make more vaccines, more vaccinations, Q with wave, let's say. So when we equalize marginal social benefits with marginal social costs, we will have Q with wave, and this is Pareto efficient. And you see here the problem of underconsumption. You see that we make vaccinations less than it is efficient for society. And this is exactly the problem of underconsumption. Also, we need to show here dead weight losses from this positive externality. So now we consume this number, blue number with Q star number of vaccines. I will have such private benefits, yes, but society with such number of vaccines will have this amount of benefits. And it's better for society to have more vaccines, more people to be vaccinated. So you see this triangle, we lose. Society lose this amount of social benefits. This is the loss of society, dead weight loss. Let's see. Social loss from underconsumption. Okay, and what to do with such problem? How government can achieve efficient amount
Taxes, quotes, like
taxes or subsidies here?
subsidies.
We should subsidize people. Yes, we should give people money to make to stimulate people to go to make vaccines. Yes, and you can show here this per unit subsidy that that is called Pigouvian subsidy. Yes, this is per unit subsidy. We should increase marginal private benefits by how much? By this exact number. Yes, we should increase marginal private benefits such that they will be equal to marginal private benefits plus subsidy, per unit subsidy, that they will be equal to marginal social benefits. So we will make people to think about society in total. So we increase this, and if marginal private benefits moves here, people will get more vaccines. You see, we will move to this equilibrium.
May I ask a stupid question?
Please, yes.
I'm not sure, like, but can subsidies be counted not in money terms? I mean, for example, can we consider as a subsidy, I don't know, pen or something like a hoodie, or I don't know, because why should government pay for people so that they will like go and do a vaccine, but like maybe it is not like wise for the government, but maybe they will do something with material things.
Yes. They provide the subsidies not always in money terms. Yes, but for our analysis, we how to say,
recount them. I don't know.
Yes, we recount them in money terms to compare these situations. But you can think that this subsidy is I don't know, the price of hoodie, and I will give you hoodie, and and we will increase your probability to be vaccinated by yourself. Okay.
Thank you. Yeah.
Yes, that's a very good question. Thank you. So, and if we have this subsidy, so marginal private benefits increase, and we will not have deadweight losses in this situation. Yes, we will be in efficient equilibrium, Pareto efficient for society. So, okay, guys, we will stop here. Please raise your hands who answered. I will write down it. Okay. Today I saw the new. Why he didn't raise? The new. Yes, you.
I think he left. No, he's here. Sorry.
Угу. Так, Елизавета, Даян. Угу. Настя. Иван. Максим. Два Максима. Угу. Елисей. И Данил. Добро пожаловать в клуб тех, кто отвечает. Ребята, вы тоже можете присоединиться к клубу тех, кто отвечает. Вы можете что-нибудь спросить, вот, и получить свои 3 балла. Не знаю, мне кажется, это приятно. За просто что-нибудь сказать. Вот. Все, окей. Так, ну чего? Сейчас давайте посовещаемся. Ну, смотрите, да, у нас одна задача по этим экстерналиям, вот, а на следующем занятии у нас начинается макроэкономика. Я думаю, в макроэкономике там, конечно, тоже, да, как бы не очень мало заданий, да, поэтому Вот как вам лучше? Я могу с какой-нибудь группой, а?
Было очень удобно, когда вы видео выкладывали. То
Да?
есть, да, прям.
Давайте, да, я сейчас все равно, я с другими группами, там на одну задачу быстрее иду, и я точно с ними успею последнюю пройти, вот, и вам, когда будет удобно, вы ее просто посмотрите.
Хорошо, да, давайте, спасибо.
Ладно?
Да.
Да, хорошо.
Но если вам нужна консультация, вы мне, пожалуйста, напишите и скажите, вот нам нужна консультация, разберите это, да, там прям вот по пунктам, да,
Можно
какие задания
вопрос?
разобрать. Да.
Смотрите, нам пришла информация по поводу экзамена, что он будет разделен на 2 части.
Да.
Одно домашнее задание, второе это оффлайн. Но формулу нам никто и так не сказал, какая у нас в итоге формула оценивания. Можно ли как-то этот вопрос выяснить? Может быть, через лектора или как-то узнать в итоге, как у нас считается наша оценка overall?
Не,
Вот.
ну смотрите, там, ну, во-первых, мы к формулам, ну, там, семинаристы к формулам никакого отношения не имеют, вот, и, ну, вы же ходите к Юрию Владимировичу на лекции, может, вы у него спросите, как он там...
Хорошо,
Вот.
хорошо.
Ну, не, на самом деле, это к нему, потому что если вы спросите сейчас у меня, я все равно буду тоже ему писать, это тоже будет
Понятно. Я просто на всякий случай, может быть, вы знаете, так что я на всякий случай решила вас сначала. Все равно у нас лекция только, ну, сначала ваш семинар, а потом лекция идет, так что, да.
Так, подождите, мы опять отстаем? Нет,
Нет, все нормально, просто по расписанию у нас лекция, которая именно вот так вот проходит, как бы онлайн, идет только одна, и она, по-моему, в пятницу.
Да, по пятницу.
Да, а так у нас видео выкладывают, так что пока не было возможности.
Понятно. Ну, спросите меня, ну, думаю, да, там пополам будет. Ну, не знаю, но уточните обязательно. Смотрите, у вас это же просто шикарно, да, вы половину
Мы
экзамена...
согласны. Не, мы наоборот ничего не имеем против. Да, так что спасибо. Всё.
Ладно, так, Даян, вопрос какой-то?
Я думаю,
Нет, я
это...
просто опять забыла.
Да.
Хорошо, ладно, все, ребят, не буду вас тогда больше задерживать, я тогда выложу вам последнюю эту задачку.
Спасибо
Посмотрите,
большое.
пожалуйста.
Спасибо, хорошего дня.
Спасибо.
Вам тоже. До свидания.
Спасибо.
До свидания.